Hello viewers, so today we are taking an important concept in functions, that is domain of real functions. So before taking the concept of domain, let us first define what is meant by a real valued function. So as the definition goes, a function f from set A to set B is called a real valued function if B is a subset of R. Clear? Now let us see what is the meaning of this subset of R. Viewers, we have seen in our earlier videos, suppose we have a function f from set A to set B. Clear? Then this function f is called a real valued function if this set B is a subset of R. R means the set of real numbers. Set of real numbers. Clear? Now B maybe, say, if B is an interval, say if we have B as -6 to say 3, then obviously this closed interval, which is closed from both sides, is a subset of the set of real numbers. Clear? Now if A and B are both subsets of R, clear? For example, if A is also a subset of R, that is set of real numbers, similarly B is also a subset of R, then f is called, this function f is called a real function. A real function. Clear? So here this interval is a subset of R. Clear? We can also take up an interval, say -1 to say 0. This is also a subset of R. Clear? So let this is the number line. Clear? And this is -infinity and this is +infinity. Clear? Suppose we have 2 points here, say A and B. Then this interval, see this interval A comma B, and this is closed from we use this symbol. Clear? So this is a closed interval from both ends. So it contains all the real numbers x such that x belongs to R. Clear? And x is greater than A or equal to B or less than B or equal to B. So here this interval, this is called an interval. Clear? The endpoints are A and B, and when we use this symbol, then it means this point is included. Similarly, when we use the same symbol at this point, it means this point B is included. So here A comma B is a subset of R. Clear? So therefore, what is a real valued function? A function f from set A to B is called a real valued function if B is a subset of R. Clear? Now let us take an example. Clear? Suppose we have a function f from the set of real numbers to real numbers, and we have a function fx is say x square plus x plus 5. Clear? So obviously this function f is defined from the set of real numbers to the set of real numbers, and hence this function is a real valued function. Clear? So viewers, now we will define what is the meaning of domain of real valued functions. Clear? So mathematically, to define a function, uh, one has to provide its domain, codomain, and the range. Clear? Uh, Suppose we have a function, say fx equal to, say this is x plus 1. Clear? Now before defining the domain, let me quickly revise some terms related to function. Suppose f is a function from set A to set B. Now this is set A, this is set B. This set A is called the domain and this set B is called the codomain. Clear? Now suppose if we have an element x in set A and the corresponding element y in set B, and if x and y are if y is the image of x, then we write it as y is equal to fx. Clear? So this set A is called domain, this entire set B is called codomain, and all those elements of set B which are images of the elements of set A constitutes the range. Clear? So range is a subset of codomain, and in many cases the range is equal to codomain, but generally range is a subset of codomain. When range is a subset of codomain, there may be some elements in set B which does not have any pre-image in set A. Clear? So let us see this function fx is equal to x plus 1. So what is the meaning of domain of f? Domain of f. Domain of f means all values, all valid values of x which gives fx. Now what does it mean? It means here we have to take all those values of x in fx which makes it a valid statement, or all those admissible values of x. Clear? Which gives us an image in set B. For example, if we take x is equal to 1, so 1 belongs to the set of real number, because this f is a real valued function and f is from set of real numbers to set of real numbers. So x equal to 1 gives f1. f1 means 1 plus 1, that is 2. So 2 is the image of 1. Clear? If we write it like this, say this is set A, means this is set of real numbers R, this is also set of real numbers R. Here we have 1, so the f1 is the image of, f1 is the image of 1. Clear? f1. So what is f1? f1 is 2, so the 2 is the image of 1. Clear? So the domain of a real valued function means all those valid values of x, the set of all admissible valid values of x. Clear? Suppose we take a function, say fx is equal to 1 upon x minus 2. Clear? Now this function, see this function, this is fx is 1 over x minus 2. Now clearly we see that here if x is equal to 2, then f2 becomes 1 over 2 minus 2, that is 1 over 0, and it is not defined, or it is infinite. So this function fx, although it is from the set of real numbers to real numbers, but here the domain is not the entire real value, real numbers. So here we'll write the function f from r minus 2 to the set of real numbers, or we'll see it later on, but here we can restrict ourselves to the domain of real functions. Later on we'll find the range. So here we'll talk about only the domain. So if x is equal to 2, so f2 becomes 1 over 2 minus 2, that is 1 over 0, that is not defined. So the domain is, here the domain of f is r minus 2. So we'll exclude this value of x equal to 2 from the set of real numbers. Clear? So this is the meaning of domain. Let us take one more example. Suppose we have fx is, say, x minus 2 over x plus 1. Now what is its domain? So clearly we see that the denominator becomes 0 when x is equal to minus 1. Okay, so x is equal to minus 1 is not admissible. Therefore the domain of this function f must have, or must consist of, those values of x which makes this function valid. So the domain is the set of all real numbers excluding minus 1. Clear? Viewers, let us take this example. Find domain of fx equal to x square plus 3x plus 5 over x square minus 5x plus 4. Now this is a rational function. What is a rational function? A rational function is a function in which the numerator and denominator are polynomial functions. So this is a polynomial, this is also a polynomial. Clear? Now domain means all the valid values of x which makes this function defined. So here the denominator is x square minus 5x plus 4. So if the denominator becomes 0, then fx is not defined. Clear? So we have to exclude those values of x which makes the denominator 0. So here x square minus 5x plus 4 equal to 0, and when we factorize it, say by x square minus 4x minus x plus 4 equal to 0, then we have x minus 4 minus 1 x minus 4 equal to 0. So we have x minus 1 x minus 4 equal to 0, and the values of x are, x is equal to here 1 and here we have 4. So when we'll have x equal to 1, the denominator is not defined. If it means the denominator becomes 0, and for x equal to 4 also the denominator becomes 0. So therefore the domain of fx is the set of all real numbers. We'll take all the real numbers excluding these two numbers. excluding these two numbers. So this is the required domain. Clear? Viewers, let us take these three problems. These three problems are the most conceptual problems. Here we have to find the domain of fx is equal to 1 over x. Now this is called reciprocal function. This is called reciprocal function. We will discuss it later on in our videos. So this is known as reciprocal function. This is called the quadratic function. Quadratic function. Clear? And this is this is called the quadratic function. I'm sorry, this is not the quadratic function. This is the quadratic function here. Clear? This is the quadratic function, and this is the square root function. Square root function. So the first one is the reciprocal function, the second one is square root function, and the third one is quadratic function. So let us find the domain one by one. Now here we see that fx is 1 over x, and for x is equal to 0, if we substitute x equal to 0 here, then fx or f0 is not defined. That is, f0 becomes 1 over 0, which is infinite. So for x equal to 0, this function is not defined. So therefore its domain consists of all real numbers excluding 0. So we'll delete this 0 from the set of real numbers. So this is the domain. Clear? Now let us take the domain of fx equal to square root of x. Now this is the quadratic function. So obviously we have x inside this square root sign. So x must be greater than 0. Clear? Or equal to 0. So here inside the square root sign, those values of x are not valid which are negative. Clear? Because say if x becomes minus 1, so what is f of minus 1? This is square root of minus 1, and it is iota, and this is a complex number. This is a complex number. So but we are talking about the real functions. So the domain and codomain has to be the set of or the subsets of real numbers. So here in square root function, the value of x must be a non negative number or a positive number, including 0. So here x is greater than or equal to 0. So if I draw the real number line, so here suppose we have 0 and this 0 is also included. So the domain of this function f is from 0 to infinity. Clear? And here we have the 0 is also included, so we have put this sign of interval. Clear? So this is closed from this side 0. Clear? So the domain is 0 to infinity, and which is a subset of the set of real numbers. Clear? Here I am writing it. So the domain is 0 to infinity, and it is a subset of R. Clear? Now let us take the domain of fx is equal to x square. So here we see that this is x square and the domain is the denominator is 1. So obviously this is quite evident from the appearance of this function that this function is valid for all real numbers. So the domain of this function fx is the set of real numbers. Clear? Suppose let us take one more example here. We have to find the domain of, say, fx is equal to square root of x minus 1. So as we have done in this problem number 2, the domain of fx consists of all values of x which makes x minus 1 greater than 0 or equal to 0. So if we take this negative sign to this side, we get x greater than or equal to 0 plus 1. So x is greater than or equal to 1. So if I draw a number line here, this is minus infinity, this is plus infinity, and suppose here we have 0 and here we have 1. So the domain is x greater than or equal to 1. So this is the domain. So the domain consists of is from the interval closed interval from this side, that is 1 to infinity. Clear? And this is the interval, and obviously this is a subset of R. So for this function we have the domain as from 1 comma infinity. Okay, viewers, let us take one more interesting example. We have to find the domain of fx equal to 1 over square root of 1 minus x. So here obviously we see that inside the square root sign we cannot afford to have a negative number because we are talking about real functions. So 1 minus x must be greater than 0, and moreover 1 minus x should not be equal to 0, because in that case f becomes infinite or not defined. So we cannot have 1 minus x should not be equal to 0. Clear? It should not be equal to 0. So we have here we'll solve this inequality here. So we have one this is minus x is greater than minus 1, and if we multiply both sides by negative sign, this becomes positive, this becomes positive, and the inequality gets reversed. So we have x less than 1. So if we have the real number line as this, and suppose this is 1, so here we do not have the equality sign. Clear? So we will write we'll encircle this one here, which means that when we'll write the domain in terms of the interval, then this one is not included. So x is less than 1. So we'll go from this side to this side. Clear? So the domain is the domain of fx is from minus infinity to 1. Clear? So here we have the open interval, and obviously minus infinity to 1 is a subset of the set of real numbers. Clear? Viewers, let us take this example here. Find the domain of fx is equal to square root of 4 minus x square. So again here we see that inside the square root sign we cannot have a negative number, because in that case fx will become a complex number, and we are only talking about the real functions. So 4 minus x square here must be greater than 0 or equal to 0. Clear? So we can now solve this inequality by taking 4 to this side. So we have 0 minus 4 which is minus x square. This is greater than or equal to minus x square greater than or equal to minus 4. Multiplying both sides by negative sign, we have x square. The inequality gets reversed, so this is 4. Or we can write it as x square is less than or equal to 2 square. Now we know that if x square is less than or equal to, say, some number a square, then x lies between minus a to a. Clear? So here the solution of this inequality is, we can write here minus 2, and this is x and this is 2. So x belongs to the closed interval minus 2 to 2. Clear? So this is the domain of this function fx equal to square root of 4 minus x square. So this is the interval which is also a subset of R. Geometrically we can write here, this is minus infinity, this is plus infinity. Now here we have minus 2 and here we have 2. So these both the points, that is x equal to minus 2 and x equal to 2, are included here because of this sign. Clear? Because of this sign. So we can shade this area here, this line, and we make bubbles here indicating that the endpoints are also included. Clear? So the domain of fx is equal to minus 2 to 2, and each x belongs to this domain. Clear? Viewers, let us take this example. In the previous example we took 4 minus x square. Now we are taking x square minus 4. So again we can explain it on the same lines, that the domain will consist of those values of x which will make this x square minus 4 here greater than or equal to 0. Clear? Now x square is greater than or equal to, we take this negative sign to this side, so it is greater than or equal to 4. So x square is greater than or equal to 2 square. Now here we will make use of one result, and the result says that if x square is greater than or equal to a square, then we'll have suppose this is the real number line, and this is say minus a, and this is say plus a. Clear? Now when x square is greater than or equal to a square, we'll take only those values of x which lies from this shaded region. Will exclude this middle region here. So our x must lie from minus infinity to minus a, and we'll take help of union. This is the sign of union, and then we have the interval a and to plus infinity. Clear? And here we'll have the closed interval. Here also we'll have the closed interval. Clear? So here the values of x are here. So here a is equal to 2. So therefore the domain of fx is x belongs to, we have minus infinity to, we have minus 2, and union, and then we'll have 2 to infinity. Clear? So this is the required domain of fx. Clear? So whenever we'll have x square greater than or equal to a square, we must remember this rule. Clear? So here we'll include this part and this part as domain, and since the equality sign is here, so we'll take the endpoints and we'll exclude this middle portion. Clear? Viewers, we have solved many problems. Let us take this problem. This is a very easy problem. We have to find the domain of fx is equal to x minus 2 over 4 minus x. So here this function fx is a rational function because this is a polynomial, this is also a polynomial. This is polynomial 1, this is polynomial 2. So here we'll take only those values of x which are not equal to 0. So 4 minus x should not be equal to 0, or x should not be equal to 4. So therefore our domain of fx will consist of all real numbers excluding 4, because 4 will make this function undefined. Clear? So we'll exclude 4. So this is the notation for domain of fx. So r minus will put 4 within or under braces here. Clear? Viewers, let us take this problem. Find the domain of fx is equal to 1 over 1 minus x square. So obviously here we see that the domain is the denominator is 1 minus x square. So the denominator becomes 0 for x equal to 1 and minus 1, because this can be seen by solving 1 minus x square is equal to 0. So x square is equal to 1, so x is equal to plus minus 1. So here for x is equal to plus 1 and minus 1, that is f1 and f of minus 1, both these expressions are not defined here. Clear? F of 1 and f of minus 1 are not defined. So therefore the domain of fx is the set of all real numbers, and will exclude x equal to 1 and minus 1 from the set of real numbers. So we'll write it like this: 1 and minus 1. Clear? So this is the domain of f. We'll not write, see, this is wrong if we write r minus 1 to minus 1. So this is the wrong notation for writing the domain of f. So this is the right one, r minus, and we exclude these two values of x from the set of real numbers. Viewers, we have this problem here. Find the domain of fx is equal to ax minus b divided by cx minus d. So obviously those values of x are not defined, which makes cx minus d is equal to 0. So here cx minus d should not be equal to 0, or cx should not be equal to d, or x should not be equal to d upon c. So therefore the domain of f consists of all real numbers excluding this value of x, which is d by c. Clear? Viewers, let us take this problem. Find domain of fx is equal to x square plus 2x plus 1 over x square minus 8x plus 12. So again here those values of x are admissible, which makes this function fx defined. So here for finding out the domain, the denominator, that is x square minus 8x plus 12, should not be equal to 0. Clear? So we'll factorize it. Let us factorize it. X square minus, say this is minus 6x minus 2x plus 12, and x minus 6 minus 2, we have factorized it by splitting the middle term. Clear? So minus 2, this is x minus 6, and we have x minus 2, x minus 6. So here we see that for x is equal to 2 and 6, this denominator becomes 0. So the domain of f is set of all real numbers excluding this 2 and 6. 2 and 6. Clear? So this is the notation for writing the domain of fx. Clear? Let us take this problem, that is, find the domain of fx is equal to 3 over 2 minus x square. So here we see that this function fx is not defined for 2 minus x square is equal to 0. It means if the denominator becomes 0, this function f is not defined. So let us solve this equation for x. So x square is equal to 2 and x is equal to plus minus of square root of 2. So therefore the domain of fx is the set of all real numbers. Clear? Set of all real numbers and excluding these two values, that is square root of 2, that is positive square root, and minus of square root of 2. So this is the domain of this function fx is equal to 3 over 2 minus x square. Clear? Viewers, in this lecture we have discussed the concept of domain of real functions, and we have solved enough number of problems to clarify the concept of domain of real functions. In my next lecture we will see how to find the range of real functions, and we'll also see special type of functions, and like absolute value function, signum function, constant function, and so on. Similarly, we'll also discuss the domain and range of trigonometric functions. So keep watching my videos on concepts of mathematics. Till then, goodbye.